All right, this is Unit 6, Rational Expressions. A rational expression is an algebraic expression with a numerator and a denominator that are polynomials. We are going to start with just focusing on non-permissible values. So this is a value for a variable that makes the expression undefined. In rational expressions, the denominator can never equal 0. So we're just checking to see what sort of things are going to make these 0. So if we are looking here, and I set the denominator to 0, I don't even really care about what's happening in the numerator right now. What's going to make this 0 is if x equals 0. Therefore, the NPV is that x cannot equal 0. Otherwise, it's totally going to wreck what's happening in this equation. So if we look here, x minus 7 is equal to 0. X is equal to 7. So the NPV is that x cannot equal 7. Sometimes you're going to have to factor in order to check. So this is x plus 3 and x plus 1. So the NPV is such that x cannot equal -3 or -1. And in this one, it's kind of like the first one. So if I was looking at what would make for s equals 0 or r squared equals 0, it's simply that the NPV is such that s cannot equal 0 and that r cannot equal 0. If I'm going to simplify these expressions, the first thing that you need to do is you need to factor to see if there's anything that you can cross out. But before you cross out is when you state your NPVs. So in this case, I'm going to start my NPVs right now. So NPV is such that x cannot equal 2. Here I can factor. I can factor out a 3. And that cancels here. So this means that my simplified expression is 3, but x cannot equal 2. Now it sounds strange, but if I graph that, and this is y is equal to 3, so then that would be right here at 2, where x is equal to 2, there's a little hole in the graph because it can't equal that, so it's going to create a space where the graph is interrupted. We'll learn more about that in Pre-Cal 30, but I want to explain to you how that looks with that one. So NPVs here, m cannot equal 0, t cannot equal 0. We cross here, that gives us 4, cross here, cross one of those out. So then we are left with 4m to the power of 4. Sorry, t to the power of 4. Okay. Simplify the top here, we get x plus 5, x minus 3. Before I cross out, I state that my NPV is such that x cannot equal 3. And my final equation is y is equal to x plus 5. So if I graph that linear, however it happens to look, right at x is equal to -5. No. Yes. Somewhere. We would have a hole in the graph. Let me actually think about that. So oh, at x is equal to -3. That's why I was confused. So right here, -3. There would be a hole in the graph. Okay, let's do some more factoring. This is y plus 5, y minus 2. This needs to be factored by decomp. Two things that multiply to -20 but add to 1 is my favorite one. And it's my favorite one because it's the one I remember the most. Remember, this is factoring by decomp, so make sure to break it down. So that leaves me with y minus 2. Perfect. So then my NPV is y cannot equal 5, -5, comma 2. This cancels, and then we're just left with 2y plus 5 over y plus 5. You cannot cross out anymore. Don't do it. Stop. Okay? Next one. We factor here on the top. We are left with x minus 6, x minus 4. Factor the bottom, x, and this is x minus 6. So then my NPV is such that x cannot equal 0 and x cannot equal 6. These cross, x minus 4 over x. Okay, I'm going to factor out a negative 1 here first. And that's just going to change this to x squared minus 25. So it kind of flip-flops for me, which is nice. That means that this now looks like x plus 5, x minus 5, negative, all over x minus 5. And x plus 2. So my NPV is x cannot equal 5 and x cannot equal negative 2. So then negative x plus 5 over x plus 2. So this section will focus hard on factoring. So if you need to go back and redo some factoring, please do it. Please get the practice. You need to be able to factor quadratics by decomp, easy factoring, factor out greatest common factors, recognize special trinomials, such as the difference of squares, in order for these questions to go successfully. Take your time, go practice.